Yeah, welcome everyone to yet another Software Craftspeople India community talk. We are a non-for-profit, not-for-profit organization. Our goal is to connect like-minded people who have the craft mindset and share knowledge with them. We organize talks, roundtables, workshops to help the community get better at their craft. We are committed to spreading new ideas by inviting thought leaders at our community. So we are Incubate, the founder and sponsor of the community. Needless to say, we are passionate about delivering value to our customers using craft to build the highest quality software. We are actively hiring for multiple positions and looking out for passionate and experienced people. So feel free to join us if you care for the craft like we do. All right, so introducing today's guest, we have Yves with us, Yves Goeleven, who is an independent software architect, founder of MessageHandler.net and ClubManagement.io. He specializes in designing distributed software systems on Microsoft Azure using progressive web apps, event-driven architecture, domain-driven design, and messaging, event sourcing and messaging. So yeah, that's where the virtual stage is all yours. You can start sharing your screen.
Thank you. I will start sharing then. If all goes well, it should be visible.
Yeah.
The chat disappeared again, so you'll have to interrupt me. So it seems that when I start sharing, the chat disappears. So welcome to the Fantastic Nine. As Narendra introduced already, I'm a freelance solution architect. I am based in Belgium, so that is Western Europe, which is about 5.5 hours time difference from where you guys are. I have 23 years experience now, so I've been doing architecture for quite some time, mostly in the Microsoft ecosystem, not exclusively, but let's say 99% was Microsoft dedicated. I am also very heavily on the Microsoft Azure side. So I have been an Azure MVP for about a decade. So from the very beginning that the platform existed. My job, at least my mission, is to simplify large-scale distributed software development, primarily on Azure. Right? So you've got to keep that in mind. Also, the examples that I will be using during the talk are Azure related. As I said, I work freelance, but today I'm employed by a Dutch company called QPark. It's a large parking operator that has about 3,500 buildings across all of Europe where people can park their car. And besides that, I have some hobby projects to keep me busy, because during the day I cannot code a lot, so I would like to code at night, and that's why I have Club Management, which is a SaaS for amateur sports clubs, and I also have a messaging framework which is called MessageHandler, which I mostly use for my own purposes. So I've been doing this job for quite some time, 23 years to be more specific, and over the years I have come to realize that the enemy of architecture is basically complexity. And complexity is something that we all try to avoid, but by trying to avoid it, we sometimes cause it as well. So there is one practice within the architecture community, architecture and design community, is the design patterns. But there are so many design patterns out there. And as architects, we have the tendency to be willing to try them all on various projects. So what you then see is that you get complexity by introducing way too many design patterns. And to reduce complexity, over the years, I've come up with a model where I think that we actually only need 9 different design patterns. I don't want to specifically enforce specific design patterns on you in this talk. I will show the ones that I use, but what I want to achieve is the heuristics behind it. How do you choose your own fantastic 9 design patterns? So I will present mine, but you can pick your own, you can come up with your own preferences or whatever already fits into your environment. But I just want to give you the heuristics on how to come up with your 9, right? And I will use mine as an example. So why only 9? What is the reasoning behind it, and why that odd number 9? I think it was revealed by another software legend out there who has even a lot more experience than me, a guy called Grady Booch. I hope you all know him. If not, go and look him up. He is the author of the Unified Modeling Language. Somewhere in the 90s, I think, he came up with that modeling language. He also helped on the very first book on design patterns, which is sometimes dubbed the Gang of Four. There he wrote a foreword. And Grady mentioned on Twitter somewhere 2 years ago in 2022 that at a certain level of abstraction, all complex systems are message passing systems. And he gives some example. He says genes, for example, are a mechanism that life uses to pass information across time. And he also uses memes. I think at that time it was Dogecoin that was very popular. It's also one of the mechanisms that societies use to pass information across time. And this tweet illustrates it perfectly for me, is that software is intended to pass information over time. Time is of the essence. While in the past I was very heavily influenced by messaging already, but I was thinking about it as passing information across space, so from one location to the other. But after a while I started realizing that that is not the most important thing. It is the time that passes, the information that goes from one system to the next system, or from one person to the next person over time. So there are seconds, minutes, days, or years in between. Einstein confirms me here, because in his theory of relativity, he did prove that space and time are actually two sides of the same coin. So it's not that hard to make the switch from messaging across space to think about it as messaging across time. This also implies that I think of a database as a mechanism where you can pass information over time. So that's messaging. So for me, a database is not a data store, it is a messaging infrastructure. So I started thinking about software slightly differently, and everything for me is now basically passing information over time, dubbed by messaging. So when we look at time, we see that it only consists of 3 different divisions. We have the past, we have the present, and we have the future. And when we translate this to messaging, we have equivalent concepts. The past is represented by what is called an event. There is a child there. So the past is represented by an event. This is representing facts, and events have happened in the past, so they are certain, they have a certain outcome. Throughout my presentation, I will be representing events as orange post-it notes, so that you know everything orange is in the past, and it's an event, it is certain, it's a fact, it has happened. When we look at the present, we represent this, but what I call state. You can think of it as an object model or a database record in a traditional relational database format, but it's representing the properties of a certain noun, a certain entity, at a certain moment in time. These values are sometimes fairly stable, but they are slowly evolving, right? Like an order, it may get cancelled after a while, but it slowly evolves over time. So it's less stable than an event. And then for the future information, we also have data about the future. We call these commands. They capture the intent of the user in a system. So if a user wants to cancel their order, we will create a little object in there with an order ID, and we give the type, which is called, for example, cancel order. This is like an instruction to the system for please make it so that this order becomes cancelled. But it is information about the future. and the future is uncertain. The system can say, yes, I will cancel this, or the system says, oh, no, sorry, that's not possible because it was already cancelled. Right? So there is an uncertain outcome. You're not guaranteed that your desire from the future is going to be realized. So we have three types of data: events representing facts from the past, state representing the current situation, or at least at a certain moment in time. And then we have the future, which is represented by commands, and that is uncertain. We do not know the outcome. Now, when we combine all of this, we will end up with a transformation matrix of 9 different transitions. We can go from a command to a command, from an event to a command, from state to a command, and in all other directions. This gives us 9 different transitions. So now my hypothesis is that we can build any software by coming up with a design pattern for each of these 9 different transitions. And we can chain those transitions over time next to each other in order to implement any software that we can imagine. And that is my hypothesis. I will show you my patterns, and I will give you an explanation on how I implement them and such. But it's not my intention that you must follow these patterns. You can pick your own for each of the transitions, look at your business processes that you have, and then as a team in your organization, figure out which pattern you will use for the transition. My only recommendation is do use the same pattern as much as you can, so you do not end up with 1,000 different patterns out there. Right. So the patterns that I am using for these transitions, and I will explain them to you one by one in the upcoming slides, are respectively delegation, to delegate one command to another command handler. I'm using the aggregate route from domain-driven design to transition from commands to events. I'm using a downstream activity, which is an EDA pattern, to transition from command to state, but I will explain that one later. I will use a reaction to transition from an event to a command. I will use event stream processing, which I assume everybody has heard about at some point in their lives, to transition from events to other events. I will use a projection to transition from events to state. Then I have task processing, which will also be the first one that I will cover as a process. This is often performed by humans. When they work on a screen, they look at a certain state and then choose what the command will be that they want to invoke. But it can also be automated. So I call this task processing, or in the case of a human, is a task-oriented user interface. To transition from state to events, I will use an event generator. And then finally, to transition from state to state, I will use a state transformation. This last one is from the SOA patterns set from a long time ago, but I'm still using it. So depending on the system category that you're going to build, you will not necessarily need all 9 of them. So I have here identified 3 different system categories. And for each of these categories, you can actually build the entire system with only 3 to 5 of the 9 patterns. Okay, so even 9 is actually an overcomplication of things. If you're building line of business apps, you need 3 to 5. If you do Internet of Things, you need 4. If you do BI, you also need only 4. Right? You don't need all of them at the same time. But all 9 of them collectively can be used to build any of these 3 system categories. So let me discuss line of business first. To show you the graphs, I'm using a modeling technique called event modeling. If you follow me on LinkedIn, you will probably have seen this technique used. At the top of the drawing, you always find people who are interacting with a certain process, in this case, a business process. And at the bottom, you will find software capabilities that will interact with that human to realize a given business process. Now, when we look at the interaction between a human and the software in a typical line of business system, then you will always see the same patterns repeated. I've only drawn it once here, but when you make a full model, you will see the same transitions repeated over and over again. First of all, you typically have the human that is looking at data on a screen and then deciding which task needs to be performed on that data. So in this case, a customer is looking at, for example, a web shop. We are showing them a list of products, and they will then select the product and place an order for that product. So it's the human that is performing the task processing transition here. And then the system needs to act upon the order. So the customer places that order and the system needs to decide, will I fulfill this order or not? And it's a little process, and that process is called booking. So the software starts the booking process and will write this down. I have started the booking process. In this case, an event that representing a fact, and it says the booking started. As a result of that, the customer can start tracking their order. They will see a sales order, maybe it still has a status pending or whatever, but this is a visualization that has been derived from the decision that the booking process has started. And that is then the next transition, and for that I use a projection. So to clarify this all a little bit, so task processing is the act of making choices based on the current state of things. So in our previous example, it was a customer looking at available products and then making a choice of which product am I going to place an order for. So they make a choice. They look at current state and then they will invoke a command as a request to get that choice realized. So you use this pattern every time that a task needs to be invoked after a given condition has become true. Now, there are multiple variations of this pattern. For humans, we tend to call this the to-do list. We just give them a list of options that they need to perform, and then they will invoke the correct actions on it. But it also comes back sometimes in what people call a cron job. Task scheduling, like this task needs to be performed at a certain moment in the future. So when the condition of time is true. So that is a combination of things that get fit into this one pattern. But it's always the same. We are looking at the current state, and when the state fulfills certain conditions, then we invoke a command on the system. So when the conditions are unknown, like in the product catalog example, I will typically delegate this to human beings, almost always. So I will give humans a list of things, in this case, set of products, and then I will let them make a choice. AI might change that. We know the semantic kernels and lang change that we're seeing today, where an AI can also make a choice. Maybe in the future, I will not delegate it to humans anymore once I trust those, but for now, I don't trust them. So we can still delegate that to humans. But when the conditions are known, but the only thing that isn't fulfilled yet, it is not the right time, then we can use several techniques. I already mentioned one, cron jobs is one technique, but another one is, for example, to use to embed the state that you want to act upon in the command and then delay the command. So a lot of messaging infrastructure like Azure Service Bus or RabbitMQ or whatever, they all allow you to do delayed delivery. So you can embed the state inside the command and then just postpone the command until the time is right. So in this scenario, it's a GDPR cleanup that's required for personal information, needs to be removed after 1 year. So you can put the personal information details in a command and then schedule it for within 1 year. So those are techniques for when you know the conditions, but it's just not the right time yet. There is also more complicated scenarios. In this case, also, for example, GDPR related. Not aware if you know the regulation in Europe, but we need to give people a lot of control on how we want to, or how we can send them emails, for example. They have the right to set certain preferences, for example, that they only can get an email once a day or once a month. So when I want to send people in Europe an email, I need to combine multiple conditions together. First of all is the context for the email itself, but also I need to keep in mind those preferences. So I need to join two data sets together, and only when they match, then I can invoke the command. So in these complicated decisions, I would probably use some kind of a background service that is monitoring the two database state tables. So that is email, content, and the notification preferences. And only when the two conditions are met, then the actual send email command can go out. Right? These are more complicated scenarios. It's typically custom software. Can be built with some frameworks like Hangfire or in the .NET space. I don't know if everybody knows the .NET space, but there typically are some frameworks that allow you to do this kind of complex scheduling mechanisms. But all of that is for me the same thing. It is a human or some software looking at state, and when the conditions on that state are met, they will choose what needs to happen. The system is still responsible for making a decision whether or not that command may actually happen. I personally use the aggregate root pattern for this transition, so from a command to a decision, which is an event. But in the ecosystem, we also see another one called the decider very often. It's a purely functional version of this pattern. And also the image is a little bit imagined by a guy from the past that takes decisions. He looks like that at least. But that is the core here. So there is a command coming in, and the system needs to decide what is allowed. Is this command allowed to be executed? So the aggregate root pattern in this case, it takes in that command, and it will then take a meaningful business decision and store that business decision. So it will keep track of it, right? I use, that's the next slide then, I use event sourcing for this specific purpose. So I will write down those specific business decisions in my database table, and I will remember them. So I will remember all the past decisions stored in a database. This has plenty of benefits for me. It allows me to track the full history of everything that happened in a business process. But it also has technical benefits, like, for example, easy deduplication. A lot of people in distributed systems struggle with idempotency and deduplicating data. This is very easy when you have recorded your past decision. Right? If you have to take the same decision again, you can look, I already decided this, so it's probably a duplicate. Right? So that makes a lot of hard tasks in distributed software design a lot easier. I don't always distribute. I think it was Martin Fowler that said first rule of distribution is don't. I apply that. So if I don't have to distribute, I don't. But when distribution is needed, I will put a helper pattern next to the aggregate root, which is called an outbox. And the outbox will consume from the stored events in the database and then publish them to wherever they need to go. That could be a broker, that could be a streaming engine, that could be whatever. And then projection. So human beings are not really very good at reading event logs or audit logs. They want to see the current state of things, the current state of the system. And in order to turn that event stream that is stored in the database back into something that a human can interpret, we will use a projection. Projection is a very fancy name for a class that copies data from an event object into a state object. And it just iterates through the events, and whatever information that it needs it will copy it over into the state representation that's going to be shown to the user. So it's basically just a mapper. I have two different flavors of this pattern depending on who is asking for the information. So if it's the same person asking for the state of their order, for example, as the one that also invoked the command, so in this case the customer that is placing their order on the website, then I will use what is called session consistency. So after the event is stored in the database, I will just load the same events from that person on the go and transform it into something readable in the request itself. So there is no eventual consistency here. It's just we download all the events from the store, run the projection, and then show it the result to the user on the fly. If it is another person, I do it differently. So in that case, I will use eventual consistency. So let's say the seller also wants to look at that order, but that seller can wait a little bit. He's probably not even watching their screen. He's probably playing Fortnite and then gets a notification, and then 5 minutes later he's going to watch. So we have time in between the actual placement of the order and when that seller wants to go and have a look at it. So we can make use of that time to actually distribute the data to a location where it's easier to query for that specific seller in this case. So I will leverage the outbox again, so which will pull the events from the data store where they are stored, then distribute to a given location where it's easier to query, and we will project the data into that database. And typically this is another type of database, so where the event is usually just a key value store. The event store is just a key value pair store. The state is very often, for example, a search index, something like Lucene or Azure Search or Elasticsearch, or it could be a document database or whatever makes sense for the scenario at hand. I will also typically use multiple database types depending on how it's queried. So, and this is often called polyglot persistence, where we choose the database of choice is changed per use case basically. And depending on how the user wants to query the data for that specific use case, we pick a different database. And then, of course, the UI will just pull the data from the database. It might take a few seconds before the data gets there, but it's not a problem because it's a different person and that person is probably not there anyway. What you've seen so far is pure command query responsibility segregation plus event sourcing. So you might have heard about these techniques already in the past. That is where this this inspiration comes from. But typically there are two more patterns that are very useful to combine in these business processes, because as I said, probably one of the humans involved in the process is playing Fortnite. He's gone. He's usually not actively monitoring the screen, and we need to reel them in, basically. We need to let them know there is something going on in the system that you need to respond to. And in order to do that, I tend to use a combination of a reaction pattern and a delegation pattern to notify that person. So a reaction will invoke an action in response to an event. So it will invoke a command in response to an event. And we always use this pattern when we need to take action in a reaction to something else that has happened before. For example, if an order was booked, we need to let the seller know that there is a new order coming in. Depending on the needs, I will either go for a transient reaction or a persistent reaction. And often this depends on legal requirements. For example, if I just want to notify a seller that a new order comes in, and that seller might have their desktop application open in the flow, then I will typically use a transient reaction because I have no legal requirement to tell the seller that there is a new order. That seller might be looking at the screen, he might not be looking at the screen. It doesn't really matter. He might not see it anyway. So I'm going to go some kind of a transient channel like WebSockets. In the .NET world, this is called SignalR, but it's the same thing. So their, for example, their web app or their phone app is going to be subscribed to the events, and we will show a notification on the screen whenever some of the events come in. Is the user not watching? Then he missed it. Is the channel itself losing the message? So be it. Okay, then there is no pop-up. That's it. This is transit. But sometimes we have a legal obligation. So for example, in Europe, we are required to send the payment notification. Every time somebody has performed an online payment, we must notify them about that. Typically, this is associated with the order confirmation when somebody places an order. So in that case, we need to use a durable transport mechanism that quite guarantees the delivery of the confirmation to the user. I know it's email in this case that I'm going to be using as an example, which is not really guaranteed either, but it's the best effort and the email probably arrives. But in this case, I would again make use of the outbox, which will then pull the event from the store, send it through some durable mechanism like a queue or a stream, something like Kafka or Event Hubs or something similar, and then a handler that invokes a command, and the command itself also needs to be durable. But the important thing here is guaranteed delivery, so that we know that eventually the command will be executed and the person will be notified. Now, email and other things very often need to be delegated to a third party. And that's where I use a delegation pattern. I use this pattern every time I want to delegate the execution of a command to another component or even very often another party. And this is typically where I use this pattern, because some things are so complicated. They look simple, but they turn out to be incredibly hard. Getting an email to arrive is super hard. You need to comply to SPF, DMARC, DKIM, all kinds of protocols that need to be put properly in place. And payments is another one. Don't try to do this at home. Please use a professional service for this, because there is no way that your email is going to arrive in the email box, or at least not very long. It might work for an hour, but then it's done. Same for payments. You will probably not get through all of the security mechanisms that need to be fulfilled there. Please delegate that to a party that is responsible and that knows how to do it. Was there a question? No, I think it's just an interruption. Okay. So use delegation pattern for these things. Don't try to do it yourself. But a delegation is nothing more than you get a command and then you give it to somebody else for execution. It just passes through. You don't do anything yourself. Right. So that was line of business. So far we've seen 5 patterns. We've seen task processing. We have seen aggregate route. We have seen projection. We have seen reaction, and we have seen delegation. Now, if you're going to build an Internet of Things system, it is slightly different. You need a different combination of patterns. So let's go to an example event model again. In this case, I have a camera. That camera is taking pictures all day. And I have a door, and the door has a smart lock. And we want that lock to open when the correct person appears on the camera. So the camera is taking a recording of the current state. So it takes a snapshot of an image as part of its video stream. It's a lot series of images behind the scenes. And then there is some software. This is usually AI-based machine learning algorithm that tries to detect certain presences on the images. But just one detection is often not enough. Very often, I think you can imagine this, the video with the red squares on it that is vibrating in search of presence of, for example, cars or people on a video. It is searching and it's detecting presence several times. And it's only when it discovers it multiple times that it actually locks in basically and says, yes, this is a human being and it's somebody that we can check. So if it has detected the presence multiple times, it can convert it into another event. In this case, I've chosen access granted, but it can be anything else. That transition from multiple input events that are kind of like lossy signals, turn that into a more valuable event like access granted. That is typically done by a stream processing engine. It takes in multiple events on the front. It does some buffering and some filtering and some joining, and then it will at the end just raise a new event. When that event occurs, it typically needs to have an effect on reality. And usually, again, I use a reaction to turn that event into a command, and then a downstream activity to make that command function on reality again. So we have to transition here from a command to state, in this case, electrical state. We need to make a pin on a microcontroller high. We need to give it a pulse, right? And then the door lock will open. And that transition is typically done by a downstream activity. So an event generator, the first pattern, is this little guy with his hammer. He's going to generate an event. This is baby Thor, by the way, the Norwegian god. Is going to cause some havoc. An event generator looks at state and then turns changes in that state into events. So it will report state changes. One example in the IoT space is sensors. So a sensor, for example, a temperature sensor, it measures that it's right now 22 degrees, and then that changes to 23, and it says, all right, there's a change in temperature, so I'm going to report this as a temperature changed event. Same for the camera. It sees a human on the image, and it says presence detected. But that's physical. We have counterparts in the virtual space as well. We have change data capture systems that look at the records in databases, and when there is a property change, it will report that. It's exactly the same thing. It's the same pattern. These are all event generators. They look at state, and whenever there is a change, they will report that change. Yeah, in Azure, we have Cosmos that has that built in, but I assume most people are familiar with the change data capture technique. And just to draw the parallel, it's exactly the same thing. Now back to the IoT case. Typically, the setup for state change detection looks something like this. We have this camera. The camera just gets a bunch of bytes. It's an image, but it's usually just reflected as a number of bytes that needs to be interpreted locally. That happens on a microcontroller typically, and they will emit discrete events like presence detected or temperature changed or something like it. It's a discrete event, but usually those discrete events are quite low quality. It's like the moving square that's just hovering up and down, and you don't really know if it's an actual presence or it is really somebody. So it's low quality and it needs interpretation. So typically that information is then sent elsewhere through a local broker, then typically a field gateway, still in the building typically, and then we go on to some streaming transport. Think IoT Hub, Event Hub, Kafka, such kind of transport that is geared towards streaming low quality signals towards a stream processing engine. And that's then the next pattern is stream processing, where you take in a lot of low quality events and you try to convert it into more high quality events. So Typically with these stream processing engines, I think the most famous ones are like Apache Spark, Azure Stream Analytics, all that kind of technologies. They allow you to join, filter, group, count, aggregate, summarize, all kinds of functionality on event streams. This is real-time streaming. So this is not stuff stored in a database, but this is data on the move from one place to another. And these streaming engines, they are just running. Events get injected, and if in a certain time window they detect something, they will emit another event that is more business valuable. So in Azure, we have Databricks is a very well-known one. This is based on Apache Spark, as far as I know. And we have Stream Analytics. All of these allow you to basically write queries. I have a select statement there. It looks like SQL, but it is not SQL. It's just a running query that looks like SQL, and data gets fed into it. And at the other end, some other event comes out. I've also seen a lot of neural networks in this place, where they use a neural network for inputs and outputs that always detects the same things. So that can also be used instead. All right. Typically, that more business meaningful event is then needs to be acted upon. So you need some kind of reaction, an event handler that subscribes to the meaningful event and then invokes a command. This is the exact same as what I explained before in the line of business pattern set. It just comes back here, so I'm not going to repeat it. Then we need to take action on reality. So we have a command that says, for example, open door, but now we need to directly change state. We don't need to take a decision. This is a hard command, and we need to change reality. We need to change the state of the system. In this case, probably an electrical signal on a door lock. And that's what we call what I call a downstream activity. This comes from the original EDA pattern set. It's quite old. If you don't know about it yet, then just look it up. But stream processing, event generator, and downstream activity, they all belong together. They are one one pattern set. So you want to use this pattern when you want to have direct influence on state from a command. So without a recording of a decision. So no event sourcing here. It is command and then an effect. So in this case, the command comes in via a queue. In Azure, that would be typical an IoT hub cloud to devices queue, but it's a queue. The command comes in. There is a microcontroller listening to that queue, typically through MQTT, and then it just changes the state of a pin. It goes from 0 to 1. Done. Okay, there's no decision logic. It's just changing the state to 1, and then the door lock will open because the electricity will start flowing or stop flowing, depending on how it works. All right, so that was Internet of Things systems. That is done by event generation, stream processing, reaction, and finally an actuator or a downstream activity. And the third system category is BI systems. And they work actually very similar to IoT systems. At least the beginning is roughly the same, the end is different. So what we see in typical BI systems is that they have two processing paths. One is called the hot path and the other one is called the cold path. The hot path looks exactly like an IoT system. There is an event generator, could be a physical one, so I've reused the camera symbol here, but it is also very often a virtual one, like a change data capture system that is reporting changes in one database and then it's being synchronized to the BI environment. And then in hot path processing, they also do stream processing. In this case, I'm going to detect some violence instead of access, but yeah, it's the same thing. We do stream processing to turn low quality signals into high quality signals. The difference then is what BI systems do with the data. typically they do not act again on the physical world, but they will compile a report for management or for some future human decision to be looked at. Typically a report, a graph, or a PDF, or whatever, right? So to turn the meaningful business events into human readable information, we are going to reuse the projection. So this is the same pattern that we had in the line of business environment, where you will turn an event into some human readable basic information. Usually this information is not sufficient for a manager to take conclusions on. So they will have to do some transformations from that basic information into nicer reports and graphs. And that's then state transformation. So projection plus state transformation together make up the cold part of a typical BI system. I've already explained 3 out of the 4 patterns here. There's only one more that needs to be covered, and that is the state transformation. So state transformation changes the shape of state. State is information about the current object model, basically, and you want to transform that into some other representation of the same data. So you're not moving back in time, you're not moving forward in time, you're still on the same point in time, but you show it differently. Think of, you see a database on the left and you see a report of that database on the right. And there is a lot of variation in this, but you always use this pattern to turn data that is stored somewhere into data that you want to show to a human or that you want to store somewhere else. And you want to transform it on the go. A typical pipeline for this in the past is ETL pipeline, extract, transform, load, where you load data from one source, you transform it, and then you import it into another source. So ETL is a typical example. In Azure, we have a bunch of technologies that just allow us to click this together. Databricks and Data Factory are like that. I also very often see human beings write C# or Java programs that just load from one database, transform, and then put into another one. That's the same thing, same technique. Other variants of this are typical queries. So you just load data from a database, you map it onto some other model, and then you expose it through a JSON API, or you turn it into a report, an Excel, or an export, or whatever you're doing. It's all the same thing. You download data, you transform it into another format, and then you visualize it to the human. There is no real difference. It's mapping, basic data in, mapping data out. Typically, there is no logic in those transformations. How much time do we have left? I have some bonus slides. Okay, we have 10 minutes, I think. Yeah. So what is often also discussed in the distributed software world is the style of integration. And very often we see 2 different camps there. They're battling each other, sort of virtually. But you have proponents of what is called an orchestration, and you have proponents of what is called a choreography. And these are different pieces of software that want to integrate with one another, but in a different way. I'm going to show you how these fit into the 9 patterns, right? Because both are actually covered by the 9 patterns. It's just up to you to make a decision. What are you going to use as a team, right? An orchestration is an integration style that is based on the delegation pattern. It is about orchestrating commands. So in a orchestration pattern, I hope you can see it in the middle. There is a gray box called orchestration. It itself receives a command, and then it will send commands to other parts of the system. So it is sending out, I would like you to do that. I would like the other one to do that. And I would like that one over there to do that. And then it waits. Whenever the other parties then respond, I've used the event here, but the response could be anything basically. But the other party will then let the orchestration know, yes, I did this. And the second party could say, oh, sorry, I failed to do this. And the orchestrator will listen to that information and then decide what needs to happen next. And typically that's also invoking a command on some other part of the system. That is an orchestration, works very well within line of business systems, because typically we are thinking about, okay, a human instructs the system to do X and then Y and then Z. So let's just automate that and let the orchestration issue command X, Y, and Z. But it kind of makes it hard when you want to integrate with a line of business, an IoT system or with a BI system, because those systems don't use commands at all. At least they typically listen to events and then process the events and then do their thing. So if you have to integrate a orchestration-based line of business system with a BI system and an IoT system, it gets a bit harder, okay? But the benefit of this model is that it's very easy to understand, it is sequential, it's linear, and it works like a human being would think. So that is the benefit, but the downside is it's harder to integrate with other system types. Orchestrations, however, are an integration style based on reactions. So that means that events are being emitted and that the different systems independently choose how they want to react to those specific events. So as dancers, each dancer decides what they want to do based on the music that they hear, but there is nobody instructing the dancers what to do individually. So in this integration style, the different systems only emit events. They will tell X happened, Y happened, Z happened, and they do not take into account whoever else is there in the environment. Those they can do whatever they want. The other components in the environment will then react to the events and issue local commands or do whatever they want to do internally. And at the end of their reaction, they will emit typically another event so that the rest of the system knows what happened, and they can also take appropriate new reactions. Benefit of this is this integrates very, very nicely with BI systems. We just need to publish all the events to the BI systems, and we can compile any report that we like in the future. It also works amazingly with IoT systems because they're used to handling events. The only problem with this model is that it's hard for humans to reason about in the line of business world. So it requires more documentation, it requires more mental effort from the humans that are implementing a line of business system based on choreography. But up to you, what fits in your organization. It fits fine with all the pattern sets, so you don't need new patterns. Orchestration is for me not a new pattern. Choreography isn't either. It is just a repetition of the existing ones that I already had. All right. I see we have 5 minutes left. We reached the end of this journey. I would like to summarize it before taking questions, but I think we should still have a few minutes for questions. So what I want you to take away from this talk or this presentation is that I want to give you a way of reasoning about your system so that you can deal with a limited amount of patterns. But you choose your patterns. You can use mine, but you can use your own. That's fine. I would like to urge everybody to start thinking of systems, software systems, and actually all systems as information flow over time. And time is important. So it's time progression that makes software into very valuable things. When we look at time, we only have 3 types of them, 3 divisions. We can translate that to data structures, commands, events, and state structures. And we only have 9 transitions between these 3 different structures. And for those 9, you choose a pattern and you use that same pattern over and over and over and over again. And if you do this, then your entire system, your entire architecture will become fairly simple, because all you need to know is 9 different patterns, and that's it. If you want, you can have a look at my message handler framework. It has all of these patterns implemented. It's C#, it's Azure, it's very dedicated to that environment. So if you're not in C# or not in Azure, then you cannot use it. I'm sorry for that. But you can at least then have a look at it for inspiration and maybe build your own for your environment. But yeah, you can have a look at it. There is also an end-to-end scenario for a line of business app. I haven't come yet to building an IoT system as an example, or a BI system as an example. So it's only line of business for the moment, but you can have a look at it. And I hope it's inspiration for everybody to start thinking of systems as information flowing over time. All right, I think we have 4 minutes left. So if there are any questions that I can take or answer, then I'd like to hear them. I'm opening chat so I can see if there is anything. Can you share a specific example when using a certain heuristic led to a great design decision or helped to avoid a bad one? A specific example of this. Now I need to have a look. So the entire idea here is that it's not specifically to prevent a design decision to happen, because we need to take decisions all the time. But what these heuristics try to achieve is to be consistent in your decisions. So that if a team starts developing software today, and software lives for like 30 years, that in the next years, the decisions are taken with the same heuristics in mind, so that you don't get any drift there. So does this help to make better individual decisions? No, but it does help in keeping the decisions consistent as the team progresses in developing the software. So can you share a specific example for a specific design decision? I can't, but I just need to stress that this is for simplicity in the long term, so that you keep reusing the same patterns. Do you use any specific tooling to build the event models? Personally, I use Miro, which is a pretty well-known whiteboard drawing tool, I think. It works fine for me. I've heard other people use FigJam by Figma. I do not know if there is any specific tooling for event models. I think some people tried. I've seen ONode, I think, as a really dedicated tool, but I'm not using it. I'm using Miro. Next question, is this now the only way you design and implement systems, event modeling and the patterns? The answer is yes. Yeah, I will always use event modeling for all the things that I built, and I will choose a pattern. Will I always use the same patterns from now and in the future? Then the answer is probably no. I will eventually discover new ones, and then if I find them better, then I will gradually transition into those. One example there might be the aggregate root decider transition that I see in the community happening. I might follow, but I don't know when. And also, I do not per se force my patterns on my teams either. So if my teams have a specific pattern in mind for a given transition already, then I allow them to use that. It's not that I will enforce my flavor onto my teams. Geert, referring to the first question, the 9 patterns plus the examples of where they are best applicable can be used as a heuristics. I think it's an answer by Geert, right? I know Geert, we worked in the past together, so I think it's an answer. Do you prefer, this goes too fast. Do you prefer slim events plus real-time query versus fat events, or is there a place for both? Okay, yeah, good question. There is a place for both. Within the capability itself, I use slim events, but for integration, I might actually summarize them at the end. So let's say you have an order booking process, and I want to do let's say I need to confirm the payment, I need to confirm sales availability, I need to confirm deliverability, whatever. I need to confirm a lot of things in detail as a manager, then I will record that as fine-grained events. But BI might not care. BI might just care, I'm finished, completed, and then we send the complete sales order over to BI as part of the completed event. So there is a place for both. Last question, it's not a last, plenty. Thanks a lot for the talk and the point of view. There's considerable debate between orchestration and choreography about not just the parts involved in the system, but also about controlling the flow state. While orchestration is easier, it's not the same as choreography, yeah. Routing slip. So I think another interesting one is the routing slip. Have you evaluated in your personal 9? I treat routing slip the same as choreography, to be fair. I don't make a difference. The routing slip just decides on where the events will go at the end. It's not per se that the choreography changes there, but there is some metadata embedded in the messages that allow certain members of the choreography to ignore the events. So I don't really treat it as different. I see you mentioned that as well at the end. Okay, and then the last question, what should be the granularity for command for the choreography pattern, or can choreography and orchestration be combined? Does it create a problem in maintenance when we try to change flow? So can you combine them? The answer is yes. There's no problem to have part of the system being a choreography, sorry, an orchestration, and another part a choreography, because the choreography can just subscribe to the events that come out of the orchestration. Does it create problems in maintenance when we try to change flow? I think changing a orchestration is a lot more involved than changing choreography, because the central part is more coupled. So in my opinion, yes, it can cause a maintenance problem by using a orchestration. But it really depends on how big and how complicated you made that orchestration. If everything is in one spot centralized and it's a flow over 30 years, then you will run into problems. If you have also managed to split that one up in smaller parts, then it will be less problems. But yeah. And I think those are all the questions. No, there's one more. Have you seen worked with a module monolith where modules are built differently and combined later? Yeah, that's what I do myself actually. So the capabilities that I showed, the bottom swim lanes, I built them individually, but I don't necessarily host them individually. So I will build the modules individually, and then as the system is small, I will co-locate them in the same process. So they are a modular monolith at that point. And it's only when a certain section of it grows, I will pull that out, give it its own host, and then it will run independently. But the rest just stays in the monolith. Okay, so I will build it as if it is an autonomous component that could be a microservice, but initially I will recompose them into one host, and then when it needs to scale, I will pull it out and host it separately. So yeah, I'm not really in the, I don't follow the monolith versus microservices discussion. It is just both for me. I will build it as a module, and then if I need a microservice, I give it its own host. If I need a monolith, I will give them all together one host. But the code doesn't change. Are the slides available? Yes, they are on my blog in the talks section. My blog is just goeleven.com, so you should be able to find that. It's my last name.com. And then there is a link at the top, talks, and you should find this one over there. All right. Any other follow-up questions?
I did have one on the modular monolith thing. So even when you're, let's say, building the modules separately, as if they were to be a microservice in future, do you still use outbox or like those sort of patterns to
Yes.
kind of separate them in time and not make them transactional?
Yes. For two reasons. Reason one is I think it's good design, but reason two is Azure forces me as well. So majority of Azure storage services do not support transactions. I'm not talking about distributed transactions because there's none that supports it, but not even local transactions. So Azure Storage, Blob, or Search, whatever, I can only do one operation at a time, and it doesn't have any built-in transaction support, not even for local ones. So I have to. I have no choice but to make my operations atomic, and therefore I will first store it in an event store and then use Outbox to publish and then do a next step and then do the next step. And I have to. I have no choice but to, because the majority of Azure services would otherwise get out of sync after a while. So the environment forces me, but I'm also convinced that it's just good design. So even if I had transactions, even distributed ones, I would probably still do it this way. Yeah. All right. I see no more further questions, and people like to read my content on LinkedIn. That's good. And more coming.
And maybe people, if you have any questions, feel free to reach out to him on LinkedIn. He's really interactive, and he will, I'm sure he'll answer your question if you have any. And
yeah. So you can reach me on LinkedIn, or you can send me an email. I am not active on any other social media platform anymore. I stick to LinkedIn right now because I don't have the time to read them all. But if you want to reach out to me either via email or LinkedIn, and you can ask any question. And the link to my slides is already appearing. I see. That's good. Feel free to share it. It's no problem. All righty.
I'll spend a minute to just end here. And again, just to kind of let everyone know again, we are the Software Craftspeople India community. You can follow us to get updated about the next upcoming events. We usually plan to at least do one event a month. And if somebody might have missed it, or you would want to forward it to others, we upload our videos on the YouTube channel that we have. So you can take a look at it there if you want to revisit. And at the end, as I said, we are actively hiring. If you're really interested in the craft and you would want to join us, so send us your referrals or resumes. We would love to have a word with you. And at the end, thank you so much for taking the time out to talk with our community. Really appreciate it. And I'm sure everybody has a lot to digest. And as they digest, I'm sure they will reach out to you and ask a lot of questions on LinkedIn. At least I'll personally do for sure. And then maybe we can do a part 2 of this discussion sometime.
Yeah, I'll try to answer as much as I can. And looking forward to meeting you guys again.
Thank you so much for taking the time out from your busy schedule. And that's about it. We'll see you again.
All right. Thank you very much.
Thank you.
See you guys later.
Thank you.
Bye-bye.